going on to our next speaker. So delighted to welcome to the stage Susan from GS Biomats. Hello, I couldn't see you. So where are you?
I think I'm quite visible.
Forward clicker, back clicker.
Okay. Okay. Good morning, ladies and gentlemen. It's my great honor to be here today to share how GS Biomats is creating a sustainable circular future with FDCA and PEF bio-based materials. As global industries facing increasing pressure from carbon regulations, from plastic waste challenges, and also supply chain validity, the need for a scalable, sustainable new material has never been greater. That's what we believe in GS Biomats, PEF and FDCA-based sustainable future. So there are some highlights about our company. Our company's name is GS Biomats. We specialize in the design, development, and commercialization of furan bio-based materials. Our co-founding team, they bring more than 2 years experience in the catalytic system and furan biomass conversion commercialization industry. And also what makes us so different is we have our continuous production process for both HMF and FDCA. And we have developed a closed loop from upstream biomass feedstock to downstream monomers, polymers, and then to downstream end products. And then we have developed several non-food biomass feedstock to our products. And we have one headquarters. Our headquarters is located in Zhejiang province, near to Shanghai. And we have our R&D center there. Now our R&D center is applying for national level lab center. And we have a startup plant which has been running smoothly for more than 3 years already. And then we have a commercial plant which is under construction. Details like production capacity and all that, I will explain later in my later slides. Here is the road we have taken from upstream biomass feedstock to HMF platform compound. What we are doing is we are generating FDCA and other 100% bio-based monomers directly from crude HMF, low concentrated solution. Currently, because in the world, the majority of the manufacturers, if they want to take the HMF road, then crystal HMF is a must. But our technology is we just use crude HMF, low concentrated solution directly. In that way, we save the cost, save the energy, improve the efficiency, and guarantee the sustainability of the production. So our core technology advantages. One is our smart catalytic system. Our catalytic system is self-invented. It's a green system, and we are not purchasing it directly from the market. We are also not selling it to the market as well. This is the key, how we can keep our continuous production pipeline reactor running smoothly for a long period of time with very limited byproducts and very high efficiency. And this catalytic system can be recycled and reused for several times in the system. That is one. And the second is what I have mentioned just now, our so-called shortened production process from low concentrated HMF solution. Because the crystal HMF is very sensitive to water and air. It requires low temperature storage. It requires cold chain delivery, while our in-house HMF low concentrated solution have solved all that problem while reducing the price significantly. In the past years, our company was set up back in 2021, and this upgrading, key technology upgrading has been taken place since 2021. We have gone through a lot to improve the purity, to decrease the impurity of our monomer, and to improve our PEF polymerization technology. And you can see each year we have produced FDCA, and starting from there, we have developing our own PEF polymerization technology accordingly. You can see the color for both FDCA as a monomer and PEF as a polymer has been increased significantly since then. That has paved a way from our lab to our commercialization. And for all the past years, in the regulation ways, we have finished, we have got the USDA certification for our FDCA, which proves our monomer is 100% bio-based. And also in China, we have finished, we are the first one in the whole world to finish this new chemical registration, full registration in China. And also we have finished this REACH registration for Europe up to, at the moment, up to 100 metric ton. And also last year we have finished our LCA report through a authorized third party, which shows that compared to PTA, our FDCA, based on our current production situation, the greenhouse gas emission has been reduced by 23%. All this marks the readiness for the regulation compliant in Asia, in Europe, and in USA. And for the end-of-life solution, we have done a very initial test with our downstream partners to recycle PEF fiber. We did a very brief comparison between PET fiber and PEF fiber. So we used the chemical depolymerization for the PEF fiber, and then we got a monomer, FDME, and this monomer, the yield through the lab is around 22%, and by anticipation, the industrial scale yield can reach to more than 80%. And also, more importantly, after depolymerization of the PEF fiber, the FDME, the monomer we got, the purity can up to around 95%, which can be reused in the following procedure very easily. And about our production capacity, we have a startup plant which has been running smoothly for more than 3 years. And within the past 3 years, we have constantly delivering high qualified products to the world up to more than several hundred tons already. Last year, we delivered one single sales order to our client, about 100 metric ton. I know those numbers compared to petroleum industry is quite small, but I believe in bio-based industry, especially for FDCA, this number is quite promising. So here is the video of our loading. Okay, before we see the video, you can see here. This is our pipeline reactor. This is our continuous production process. This is the key, different from the reaction battle. And here, this is the large PT production facility we are renting, cooperating with our downstream partners to operate large amount of PEF polymerization production. And then I'm going to show you last year the loading video from our factory to our client. Actually, we are quite proud that we have delivered the so-called the very first large amount commercialized level FDCA order to our client, which marks that we have moved a step forward through the commercialization of this bio-based monomer. And for our commercial plant, this plant has been put into construction since early 2024. And now you can see the construction progress. In total, this commercial plant is designed, the production capacity by year for FDCA is 10,000 metric ton. But this will be divided into two different phases. Phase 1, we will finish by anticipation the end of 2026, which is this year. So which means by the end of this year, we will add another 1,500 metric ton of FDCA per year. And we will reach our full production capacity by early 2028. So this, we believe, marks the true transition from laboratory innovation to industrial commercialization. And later, I'm going to show you some very typical application downstream of either FDCA or PEF. Market application 1 is high transparency packaging, which we call modified PET. We use special formula to add our FDCA into it, make this cosmetic transparency, high transparency packaging for cosmetic product, which is has certain properties like slow crystallization, like the processing conditions can be much similar to PET, which means you can use your similar facilities to produce this modified PET without huge modification on the current processing conditions or facilities. And the second typical application downstream of PEF is high gas barrier packaging. Okay, I'm running out of time. Because by test the data, PEF has high gas barrier property than PET. For example, the CO2 gas barrier is 15 to 20 times better, and HO2 is about 2 times, and oxygen is about 7 times. All this makes that it's a perfect product to be applied in carbonated drinks, beer, and all that. It can extend the shelf life of the product. And currently, we are working with world-famous beer brands and soft drink companies, brand owners, to develop those kind of packaging to be applied in their whole supply chain. And another typical application downstream of PEF is textile. The material, PEF fiber, by nature, it has 7A grade antibacterial by Chinese standard, which means which is the highest standard, and which also means after 100 times to 200 times washing, this natural antibacterial property is still there. When we make the fiber, or when we make the fabric, the cloth, we do not add any other additives at all. This function, this property is acquired by nature. This because of the structure of PEF. And except this antibacterial performance, PEF textile also shows moisture absorption, fast drying, easy to obtain. All this makes it perfect to be applied in situations like sportswear, high-end outdoor, those. Next week, there is a show in Shanghai, Yarn Expo. During the Yarn Expo, we are going to launch our series of PEF fiber, long fiber, and staple fiber to be applied or mixed with different other natural materials. And also during that show, we are going to release our new brands to specifically in PEF and FDCA downstream products. So if you have a plan to go there, you're very welcome to attend our brand release. And the next market application is furan bio-based aramid fiber. We all know that traditional aramid fiber, because of its anti-flame and heat resistance, all these characters is widely used in special occasions such as aerospace, fireman jacket, and all that. We come up with the idea together with our partners. We come up with the idea about bio-based aramid fiber. After adding our key monomers into their existing formula, this bio-based aramid fiber, while remaining the traditional properties of the traditional aramid fiber, also we see improved performance such as improved softness, and flexible, and also better durability, which can expand the application scenario of aramid fiber. So except special industries can be, maybe in the future, we can see more and more aramid fiber in our daily life. So except the previous typical application scenarios, there are other applications we can also use for FDCA, because FDCA shares the similar structure as PTA. So in theory, wherever we use PTA, we can use FDCA to replace it. For example, like polyurethane electronic adhesive, or surfactant, or 3D printing, or coating. All those applications we are now dealing with customers all over the world to develop the different application scenarios for FDCA. And here is the gathering together about a brief view about where and how we use the FDCA. So overall, we believe that PEF or FDCA not only represent a new material, it also represents sustainable, scalable, and represents industrial transformation. So we warmly welcome industry partners from packaging, from textile, consumer brands to join us to accelerate this kind of transformation. Thank you so much for your attention.